Okay, so for the first learning target, you just have to recognize the type of factoring technique. You don't actually have to factor it, you just have to find which type of factoring technique you would use on it. So first thing I would do is I would notice how some of the problems, they either have 3 terms, 4 terms, or 2 terms. So I would label this as an ABC problem. So let me use a thinner marker. So this is ABC. And just by doing that, it'll narrow it down to 2 choices, maybe 3 at the most. So these are all ABCs right here. So on these ABC problems, we have to check if there's a GCF. So 4, 4, and 3, they don't have a GCF. And because it has a number in front, that means that it has to be a complex ABC. So this is D. Then this ABC, it's got a 1 in front. So right away, I know that's a simple ABC. So that's C. And then down here at the bottom, this also has a 1 in front. So that's a simple ABC. So the difference between simple and complex, simple ABC has a 1 in the front, and then complex ABC has some other number out here in the front. So we've taken care of all of our ABC problems. Now what we're going to do is, I think the next one I think stands out is a grouping question. Grouping questions, they have to have 4 terms. So if you look at number 4, that's the only one that has 4 terms. So that means that this is probably grouping. We should check if there's a GCF first, because if there's a GCF, it's always the first thing it is. So this has a 1, a 2, a 9, and an 18. So there's not a GCF here that we can pull out, and that 18 doesn't have a letter on it, so there's no GCF. So that means that this one has to be a grouping question. So this is choice A. Now the last few that are left, they only have 2 terms. So the ones that can have 2 terms are this one, and this one. Because grouping has to have 4, and ABC has to have 3. Okay, so now we can kind of tell the difference between cubes and squares, because usually squares have a 2 and cubes have a 3. So I'm looking at number 6 here, and I notice that this has a 2 on it. So first I want to see if there's a GCF between 25 and 36, which there isn't. You can check that in your calculator using the GCF button if you'd like. But I'll notice I can square root 36, and I can also square root 25, and I can square root x squared. So that means that this one has to be a difference of squares, especially because it has that minus in the middle. So this is going to be a difference of squares. Now I've got 2 left, so let's just work our way up. Let's start with number 5. So first, there's a 34 and a 12. They're both even, so that means I should be able to divide them both by 2. But more importantly, this one has an x and this one has an x. If they both have x's, that means that it's a GCF. So this one has to be a GCF. Okay, and the last one, I saved it kind of on purpose because it's kind of hard. Usually a squares has a 2 and a cubes has a 3. And this doesn't have either of those. So what you can do is you can just try to see if you can square root them. Now the square root of 9 doesn't work. Square roots only work on letters if they have an even exponent. So our next bet is to try a cube root. A cube root of 9 does work, because you would just divide the 9 into 3. And then the cube root of 64 also works. So that means that this has to be a cubes problem. So this is going to be F. So if you saw how I did that, there's no order that you have to do them in. You can do them in whatever order you want. I would go through, find all my ABCs and figure out the difference between simple and complex. Of course, always check GCF first on every single question. After I do my ABCs, then I would go to grouping, and then after grouping, I would take care of all of the terms that only have 2. Okay. Section, oh, actually, this is the first section still. So they want to know what type of factoring was done to go from the original expression to step 1. So this is the original, and they're asking, what did they do to go from here to here? Well, I noticed that they have something out in front. Usually when you put something out in front like that, that's called the GCF. If I wanted to go a step further, it looks like the next step from this line to this line would have been grouping. And then the last step would just be, reorganizing the final answer. But there's only 2 methods that were used here. It was either GCF first and then grouping second. Okay, this one you got to pay attention to the title. It's called single step factoring. And like I said before, you don't have to go in order. So what I want to do is, let's go ahead and go find all the ABC problems. So number 11 is an ABC. Number 12 is an ABC. And that's it. So I'm going to go ahead and do those first because I think they're the easiest since I showed you a life hack. I will do it by hand first, and then I'll show you the life hack in case you forgot. So on a simple ABC, so this one right here is going to be our simple ABC because there's a 1 in front. On our simple ABC, we make the list for 4. So it's 1 and 4 or 2 and 2. And then we have to try to find something that's going to give us the middle number. So the middle number is a 3. Now, I know it's a negative, but I'm just going to try to find something that could get us to 3. So it would have to be 1 and 4. Now I can consider the sign. To make it give us a -3, this would have to be a -4 and a +1. On a simple ABC, there is literally no work to do. Once you find those two numbers, they're the answers that go in the parentheses. When you have your x squared term, all you gotta do is split it up. So one of the x's goes here, and then one of the x's goes here, and then that's our final answer. Now, if you remember my life hack, the life hack for this was to use the solver. So the solver is the equation solver. Then we're going to go into our polynomial solver of degree 2. If it's got stuff in there, we can clear it out if you want. But all you have to do is enter the numbers only. So the a term is 1, the b term is -3 or -3, and then the c term is -4. Now this is a solver, though. It's going to tell us the answers to x. So the answer to x is +4 and -1. The relationship between the answer and the factors is their opposite signs. So if this is a +4, we have to put a -4 in the parentheses, and then this one right here is a -1, so we would have to put a +1 in the parentheses. Now the only difference between the simple and the complex, this guy right here is going to be complex, and I can tell because it's got this number in front. Now the way I showed you how to do a complex is we actually just convert it into the simple. So if I multiply 8 times 5, that's going to be 40. And then this is going to be x squared minus 6x minus 40. And then we make the list for 40. So it's 1 and 10, 2 and 20, 4 and 10, 5 and 8, 6, 7, 8. 8's already there. So once the list repeats, that's the entire list. So out of that list, we're trying to find something that could make a 6, either through adding or subtracting. So the only possible pair that could make a 6 would be these two. Now to get the signs right, if this is a negative on this 6, that means that the bigger number has to be negative. So that would have to be a positive on the 4. So when we have this complex ABC, you have to remember your final step. It's not going to be x plus 4 and x minus 10. What we're going to have to do is we're going to have to take that 8 that was absorbed into that 40, and we're going to have to take it out. So I'm going to take this 8 out by dividing it and dividing that. I want to try to simplify that. So if I go into my calculator, I can go into the regular calculator mode. And I can use the ABC button. And I'm going to type in 4 on top and 8 on the bottom. So that gives me x plus 1/2. And for the second one, if I type in 10 on top, so ABC, 10 on top, and then 8 on the bottom, it's going to be plus or minus 5/4. Now we don't leave our answers with fractions, so we do a move that we call bottoms up. Bottoms up is where you take the denominator, the bottom, and then you move it out in front of the x. So this is going to become 2x plus 1, and this one right here should become 4x minus 5. And that's our answer. Now the life hack still works on this one. If you go into your solver, go into the equation solver, polynomial, degree 2, you can stick in an 8. So you're sticking in the original problem. You're going to put in a -6. And then you're going to put in a -5. And it's going to tell you the answers are 5/4 and -1/2, which is kind of what we had in the parentheses. But remember, the calculator is telling us answers. The answers are opposite of the factors. So instead of putting a -1/2 in the parentheses, we have to put a +1/2. And then instead of putting a positive 5/4, we have to put a -5/4. And then we have to do our bottoms up move. Okay, so after that, I would probably go next into grouping, because those are the ones that stand out to me. So it looks like there's two grouping problems, number 17 and number 18, because those have 4 terms. When you guys do these problems, you have to always check if there's a GCF within your terms first. So if I look at 18, 2, 27, and 3, it doesn't look like there's a GCF there. Also, they don't all have letters. So that means we can go ahead and start by separating them into the parentheses. Let me back up just a little bit. I'm going to have to use a different pen because this is writing too thick. So let me go into my pens. I'll use a skinny pen, and I'm going to group it like this. I want to be able to see that plus sign on the 27. So if you take out the GCF between 18 and 2, and I'll show you again in case you forgot, the calculator does GCFs. So you have to go into the menu, go into your regular calculator mode. It's going to be option, F6, F4, F6, and then F2. So we're going to stick in 18, comma, 2. Remember, you don't put letters in this. So the GCF in the first set, it's going to be 2. And remember, that first set should always have some letters you can take out. So if that has X3 and that has X2, we're going to go with the X2 because we always go with the smaller one. So the 2x squared goes in front. And then we divide to create our new set of parentheses. So this should be 9x minus 1. And then I just do the same thing to the second set. So I've got 27 and 3. Since I have the calculator ready to go, I'll go ahead and do the GCF between 27, comma 3. And it's going to be 3. And a lot of times this second one is not going to have letters you can take out. So that positive, though, it does have to go on the bottom. So this positive right here has to be used on this second set every time, no matter what it is, because that's the number we have to stick here. So it's got to be a +3 because you need a sign there. And then your parentheses should show you what's left after you divide. 27x divided by 3 is 9x. And then -3 divided by 3 is -1. At this step, you'll know if you're doing it right because the parentheses need to match. So we're going to take our 2 green parentheses and combine them into a single set. Because anytime you have a GCF, let me explain that real quick. Anytime you have a GCF, there's 2 of them, but you just write it once in the front. So this green one, it's got 2 of them, but we're just writing it once in the front. Then we're going to go ahead and take those GCFs that I took out from each set, and we're going to use those to create the second set of parentheses. Now this one here, it still has an exponent, so you have to be careful. Because sometimes when it has an exponent, you can keep factoring, but that has a plus sign, so that's not going to work. So that's the final answer. Okay, the one right below it, we check if there's a GCF. There's 2, 1, 4, and 2, and it doesn't have letters all the way through it, so it doesn't look like this one's going to have a GCF. So we're going to go ahead and split it up, make sure that's positive goes in that second parentheses. So for the first set, it's going to be a letter. It's going to be the lowest exponent, so it's going to be a squared. So a squared goes in front. And then I'm going to go ahead and rewrite the problem with 2 less a's on each term. So this is going to be 2a to the first. And then when I divide a squared by itself, it's just 1. So it's going to be a -1. Then I have to take the GCF out of the second set. So it's a 4 and a 2. So that's going to just be a 2. And like I said before, a lot of times this second set will not have a letter you can take out. Don't forget to use the sign right here. So we're going to put the plus. So that means that down here we put the plus. And then we put our remaining stuff in the parentheses after we divide. So this is going to be 2a minus 1. And you can see again, we're on the right track because these parentheses are supposed to match. The 2 matching parentheses combine into 1, 2a minus 1. And then the 2 things I had in blue up there, a squared and 2, they have to go into the second parentheses, so a squared plus 2. Now again, this one has that exponent, but you can't break it down more because this right here is a plus. So that's our final answer. And that's our final answer, okay? Okay, so we did our simple ABC, complex ABC. We did all of our groupings. So now all that's left are the special ones that only have two terms. So I'm quickly scanning over some of them. I'm going to go find all the ones that have a 2 on them. So this guy right here has a 2. So I'm going to do this one because I can tell that's a difference of squares. And it doesn't have a GCF, so I can go ahead and square root this right away. So this is going to be 8h, and this is going to be 1. And I like this one because the pattern for this one is you just make a second copy, and then you just put a plus and a minus, and then that's your answer. So let's go scan real quick to see if there's any others that have 2s. There's a couple that have 2s. So this one has a 2. And I can square root the 16, but I cannot square root 250. So that actually isn't one of those. So if the square root doesn't work on it, that usually means there's a GCF. So I'm going to use the calculator, GCD, and it's between 16 and 250. Remember, the calculator only does numbers. So the GCF here is going to be 2. But I noticed that they both have letters, so I can also take out a U to the first. So 2U goes in front. And then I have to write what's left after I divide. So 16 divided by 2 is 8. And then when I divide out the U, it just leaves me with a single U. 250 divided by 2 is going to be the minus 125. And then if that had a U and I took out the U, now there's no U. So that's my answer. So a lot of these, you try to do the square root trick. And if it works, you continue. And if it doesn't work, then you have to factor out the GCF. So I saw another one that had a 2 down here. So I'm going to do this one next. That one has a 2. Just real quick, I want to double check, make sure that there's no GCF between 49 and 100. And there isn't, because if I divide by 1, it doesn't really do anything. So that means I can take out a GCF here, or not the GCF, I can square root them. Square root of 49 is 7. Square root of a squared is just a. And then the square root of 100 is 10. So we're going to get those matching parentheses again, 7a and 10, and 7a and 10. So then one's a plus and one's a minus. That's our answer. Okay, let's see. We got a couple more. Now these last ones. So let's do 15 and 16 first. I notice these last ones, they have 3s on them. So chances are this is the cube root. There is no GCF on these, so I'm going to go ahead and just cube root right away. Remember that the cube root's got a bigger set of parentheses on the second set. So for my first parentheses, I'm going to get 3x and 1 from cube rooting each of these terms. Now remember, this is the a and this is the b, and the pattern is AA, AB, and then BB. So 3x times 3x would give us 9x squared. 3x times 1 would give us 3x. And then 1 times 1 would give us 1. Then we use the SOAP acronym, so it's going to be plus, minus, and plus. Same, opposite, and always positive. That's our answer. Okay, the one right below it's also got a 3. So I'm going to just quickly check if there's a GCF between 1,000. Oops, I got to put in the GCF first. Hang on a second. I'm going to have to start from the beginning. F6, F4, F6, F2. I'm going to put in 1,000. And then I forgot the other number. It's 27. And the GCF is 1 again, so there's no GCF. So we should be able to cube root all this stuff. So the cube root of 1,000, so I'm going to hit Shift parentheses and put in 1,000. And it's just going to be 10. So this is going to be 10r. And then cube root of 27 is 3. So that's my first set of parentheses. Now we use the pattern to build the second set. So this is the A spot and B spot. So this would be, oops, AA, AB, and then BB. So AA would be 10r times 10r. So that's 100r squared. And then for the middle, 10r times 3 would be 30r. And then for the last spot, B times B would be 3 times 3, so that's 9. Then we use the SOAP acronym. It's got to be the same as the original, opposite, and then always positive. And that's our answer. Okay, the last one. This one has a 2 and a 5, so it doesn't look like that's going to be any of our special ones, so I'd probably check the GCF. So let me do the GCF between 24 and 16. Oops, 24. Comma 16. and that's going to be 8. So we should be able to divide both of these by 8. And they both have letters, so I'm going to take out the lowest exponent. So I'm going to have 8x squared in the front. And then I'm going to have 24 divided by 8 is 3. The x squareds go away. And then minus 16 divided by 8 is 2. If I take off 2 of those x's, that's going to leave me with 3 x's. And then that's our answer. So that's our single step factoring section. And there's not going to be that many on the test. There's only going to be 5 on that section. Okay, the next section is called multi-step factoring. So multi-step is a hint that a lot of these are going to have a GCF. So we're going to start there. So let's not use the cut. Let's use the calculator. And we've got the GCF set. So we're going to put in 3, 3, 90. So this one has a GCF of 3. Now, when you guys do a GCF, one piece of advice that I have for you, always make sure that that negative in front goes on it. So we're actually going to use a -3. So -3 and -3. We never want to leave that front term negative. So we're going to have -3 here, and then we're going to have a new problem. The new problem is going to be whatever we're left with after we divide. So this should be b squared minus b, and then minus 30. Now this is a simple ABC, so on a simple ABC, I'm going to use my life hack. I'm just going to go ahead and use the solver, and we're going to put in 1, -1, and -30. This solver gives us the answers, but then we can just flip the signs to come up with the factors. So if that's a 6, that means that in here we're going to have a -6. And then if that right there, the next one is a -5, that means in here we're going to put a +5. And then, because the b has a squared on it, we're just going to split up the b's. And then we're going to bring down that GCF that we took out in step 1. So pretty much every answer on this section should have something out in the front like that. Okay, next one. Stop using that. I need to use the calculator. So I'm going to go back to my GCF. And this is going to be, I got to go back to it, option F6, F4, F6, F2. So I'm going to put GCF between 6, 15, 9. So it says it's a 3. So I'm going to go ahead and take out my 3. 3 goes in front. And then we're going to have a new problem in this parentheses. I'll do this one in green. So we're going to have 2p squared plus 5p plus 3. And then what we can do is life hack time. We can go into our solver. Equation solver, polynomial, degree 2. I'm going to stick in a 2, a 5, and a 3. So one of the answers is going to be -1. So p minus 1. Actually, don't forget, that's a -1. So when we go into the factor, it should actually be a +1. And then when we go to the second answer, it's going to say -3/2. So I'm going to put it as a +3/2. Now, the thing about this is it's not done yet because we don't leave fractions like that. So we got to fix the fraction. We're going to put the bottom on the front of the p. So we're going to do our bottoms up move. So this is going to become 2p plus 3. This one just stays p plus 1. And then we take that GCF from the beginning and write it in front. So that's our final answer. Okay, next question. Looks like it has a GCF. Go back to the calculator. So the GCF, option F6, F4, F6, F2. We're going to put in a 5, 20. And it's going to be 5. Now, the calculator doesn't do letters, so you have to notice the letters yourself. So we're going to also take out an x because we always take out the lowest exponent. So we're going to have a 5x in front. And then our new problem should have x squared minus 4. Remember, this is multi-step factoring, so we're going to have to factor this some more. This is one of our special binomials because it only has 2 terms. So I'm going to be able to square root this one. So this is going to become two sets of parentheses with an x and a 2 and an x and a 2. One's a plus and one's a minus. And then we go ahead and stick a 5x in the front. So that's our final answer. So notice so far, every single answer in this section has something out in the front. Okay, next problem. We're going to have to go to the GCF again. We're going to do 2, 54. And it tells us that the GCF is 2. So let me take out this 2. And I'm also going to take out letters. I'm going to take out an m squared. So 2m squared goes out in front. And then I'm going to have this new problem where it's going to say m to the third minus, I'm not sure, I don't remember what 54. 54 divided by 2 is 27. Makes sense. 27. So now that 3 right there, that's a dead giveaway that this has to be a cubes problem. So a cubes problem, we're going to have to cube root. Cube root. So this is going to give me m in 3. And then following the cubes pattern, this is a and this is b. So this would be AA, AB, and BB. So now we're going to go ahead and stick in a times a, which is m times m, so that's m squared. A times b would be m times 3, so that's 3m. And then b times b would be 3 times 3, which is 9. And we use the SOAP acronym, same, so it's going to be a minus because the original was a minus, opposite, and always positive. And then we have to stick the 2m squared out in the front. That's our answer. Okay, next one, GCF again. I don't think I need the calculator for this, but I'll type it anyways. It's already set up for it. 32, 4. So it's 4. So we're going to go ahead and take out the 4. So there's a 4 in the front, and this is going to leave us with 8x cubed minus 1. So this is just like the last question. It's going to be a cubes question. So if I cube root, let's cube root this, cube root, and cube root. It's going to give me 2x and 1, AB, and then AA, AB, BB. 2x times 2x would be 4x squared. 2x times 1 would be 2x, and then 1 times 1 would just be 1. And then the SOAP acronym, same, opposite, always positive. And then we have to take our GCF from the first step and put it back in the front. That's our answer. Okay, next one, stop using that. We'll go into the calculator, GCF between 16 and 54. Just 2. So I'm going to have a 2 that I can take out, but also a b squared. Always take out the lowest exponent when they all have the letter. So we got 2b squared. This is going to leave me with 8b to the third plus 27. So this is almost like a combination of the last two questions. It's still a cubes problem though, so we're still going to do small parentheses and the big parentheses. It's going to be AB, AA, AB, and then BB. Cube root, cube root. So this is going to be 2b, and this is going to be 3. This is going to be 2b times 2b, so 4b squared. And then 2b times 3 is 6b. And then 3 times 3 is 9. Then same, opposite, always positive. And then we go ahead and stick the 2b squared out in front. That's our answer. Last one looks like a grouping question. Not the last one, but the last one in this column. But I'm sure it's going to have a GCF because we're in multi-step. 3, 6, 27, 54. So it's a GCF of 3. So we're going to divide out a 3. But you'll notice they all have x's, so I'm going to take out the x as well. So 3x goes in front. And then we're going to be left with x to the third minus 2x squared minus 9x and then plus 27. Is that 27? Let me make sure. 54 divided by 3 is not 27. 54 divided by 3 is 18. Makes more sense. Okay, so this is a grouping, so I'm just going to kind of shut this one off here and go like this. I'm going to take out the GCF of the first set. It's going to be an x squared. So x squared goes in front, and then we're going to be left with x minus 2. The GCF of the second set is going to be the minus 9. So we always use that minus sign right there at the bottom. So we have minus 9 now, and then we have x minus 2, sorry, minus 2. And then you can see that we got the two x minus 2s, and then we have the two GCFs, they go in the front. They go inside the second set, I mean, so we got x squared minus 9. Now you got to be careful because this x squared minus 9 can factor more. That's a difference of squares. So if I square root that and square root that, that's x and 3, which means the second set is a copy, but then you put a plus and a minus. Bring down this x minus 2, and then finally bring down that original GCF up here. So 3x goes in the front, so that's my final answer. Okay, next one, looks like it's going to have a GCF. I don't think I need the calculator for this one. It looks like the GCF is just going to be 2. So if I take out the 2, I'll be left with a to the third minus 2a squared plus 2a minus 4. Then I can split this up into two parentheses, so I'll split it here. This will be an a squared I can take out, so this is a minus 2. And then over here I can take out a positive 2, so positive 2 goes in front, and then a minus 2 goes on the inside. So then we rewrite this answer as a minus 2, and then a squared plus 2. Now this still has an exponent, but it has a plus also, and we can't do anything with that plus, so it doesn't split up. So that's our answer. Okay, next one has a GCF. The GCF between 8 and 64. That one is going to be 8. So we're going to take out the 8. Once we take out the 8, you're going to see this has an x cubed on it. And so this is going to be the cubes pattern. AB, AA, AB, BB. So if I cube root this, it gives me x. If I cube root 8, it gives me 2. So a times a would be x times x, so that's x squared. A times b would be 2 times x, so that's just 2x. And then b times b would be 2 times 2, so that's 4. Then we put the signs on it, same, opposite, always positive, and then we take the GCF and put it in front. So I want you to realize on this section, every single answer had something in front. That's how it's probably going to be on the test. Okay, next one. It looks like there's a GCF here. Now, this has a 1 on it, so I'm not going to take out a 1 because that doesn't do anything for me right now. What I am going to do, though, notice how they all have x's, so I'm going to take out an x. So x goes in front. Then I have x to the third plus 9x squared plus x plus 3. This has 4 terms, so that's going to be a grouping question, so I'm going to split it here. And then for the first term, I'm going to take out the x squared. So x squared, lowest exponent between the two x's, so x squared goes in front. So that leaves me with x plus 9. Now this second set, hang on a second, I think I forgot a 3 here. Because now that first one should have a 3, and that should be a 3, and that should be a 3, which means this one should have been a 3. And I knew that was going to be wrong. I knew I did something wrong because over here, all I can take out is a plus 1. So if I take out a plus 1, that would have left me with x plus 3. And if I had that 9 still over there, they weren't going to match. So now I have to rewrite my final answer. I'll do it off to the side here because I'm running out of room. So I'll put my x plus 3's first. Then I'll put my GCFs in the next parenthesis, so 3x squared plus 1. And then my original GCF, don't forget about that guy. That goes in the front, so that's my final answer. Okay, next one looks like it's going to be an ABC, but again, it's going to have a GCF because we're in multi-step factoring. So GCF between 6, 20, oh, gotta put the 6 in. And then 22, comma, 12. So it's just going to be 2. So I can take out a 2, take out a 2, take out a 2. So that's 2 in front, and then 3x squared plus 11x plus 6. And then I can use my life hack. I'm going to go into my solver, save us some time here. It's a complex ABC, but the life hack works all the time, no matter what. So I'm going to put in the 3, the 11. These complex ABCs, you guys, they're just going to give us a fraction, so we'll just have to do bottoms up. So one of them is going to say x plus 2/3, because remember we changed the sign from the calculator. Second one is going to say x plus 3. And then when we do our bottoms up step, let me do that in different colors so you can see it. This bottom has to move up to the front of this x. This will be 3x plus 2. And then this would be x plus 3. And then we can't forget the GCF. The original GCF was 2, so that's our answer there. Ooh, finally, last one. So GCF between 3 and 100, that's, I don't need a calculator for that. That's going to be 3. GCF is the biggest number you can divide out of both of them. And we're also going to be able to take out some v's. Lowest exponent is v squared, so 3v squared goes in front. And then we're going to have v squared minus 100. Now this guy still has an exponent, so there's a good chance we can square root this stuff. There's going to be a difference of squares now. So if I square root this, that's v. If I square root that, that's 10. So v and 10 go over here, and then one's a plus and one's a minus. And then our original GCF was 3v squared. So although that was pretty tedious, it's a bunch of the same stuff over and over and over. And again, the test is not going to have 30 questions. In Learning Target 2, you're going to have 5, and in Learning Target 3, you're going to have 5. But there will be a review section, so you want to make sure that you remember how to do your function stuff. Make sure you remember how to plug stuff in. Make sure you remember how to do composition of functions, f of g of x. Make sure all that old stuff from our old test is all fair game. So there's going to be 5 questions for review on this next test. And expect that to happen on all future tests. There usually is going to be a section that's going to have a distributed practice where it pulls old concepts so that we can go back and revisit and not forget.